Welcome to a lesson with Dr. Powell. Let's take a look at power functions, like x to the negative p, and let's think about when they converge or diverge. So the graphs of negative p, of x to the negative p, they all kind of look like this. So they have an asymptote, at least here for positive x values. So they have an asymptote up here and they have an asymptote right here. Now, as we mentioned before, on one side they'll converge and the other side they'll diverge, or vice versa, as long as it's not x to the negative 1. So, well, we can kind of state that in the following way. We can kind of think about going from some point off to infinity. It doesn't really matter which one. Or we could think about going from 0 to some point, doesn't really matter which one. So kind of just so we get kind of this infinite passageway in one or the other. And the question is, how can we tell, even intuitively, what these would be? Now, we can always calculate this integral out and see if it converges or diverges by taking a limit when we take an antiderivative and plug in bounds. And that's perfectly fine. We can always do that. However, let's think of some intuitive ideas for what needs to happen. Now, it'll converge if we're going fast enough to this axis. So we're kind of meeting the asymptote fast enough. So it's kind of like these values are going to 0 fast enough. Or this point right here is heading toward the asymptote fast enough. These are kind of coming close together fast enough. Now, we can get a vision for what kind of is happening when we consider the reciprocals. So instead of x to the negative p, let's consider x to the p for a minute. Okay. So for instance, let's think about the graph of y equals x squared. And maybe even, let's just kind of draw this one in. This is the graph of y equals square root of x, which is the 1/2. And right in the middle, we have y equals x. Notice how these guys are reflections of each other across this line. They're inverse functions of each other. Now, just as these are reflections, so are these, x to the negative 2 and x to the negative 1/2. These are also reflections of each other, which is quite telling. So that if you have information about convergence and divergence of this one, it'll be flip-flop for this one. So for instance, this one we saw in the previous video when we were looking at it, that going this way, it diverged. And then going this way, it actually converges. That was for this one. So that means this guy is the opposite. So for this guy, it'll be diverge and converge. So we can kind of get that. In fact, kind of how we go from this 2 to this 1/2 is they're on either side of 1. So we can kind of think when the power is, so when the power itself is less than 1, now these are positive numbers always that we're taking. So when p is less than 1, then this is the picture we're going to have. Convergence over here, divergence over there. Now, when p is bigger than 1, then we're going to have this one right here with the divergence up here and the convergence going that way. So that's kind of the schematic. Now, let's think about how we can see if things are, like in this case, like you see how this is converging. That's because it's going fast enough to the axis. Okay, we're heading to 0 fast enough. How could we see that just by looking at these graphs? Well, notice how this one goes to infinity faster. X squared it's increasing to infinity very fast. Well, if we take a reciprocal, that's like going to 0 really fast, like going down this way really fast. So it makes sense that a y equals x squared thing, or anything that when you graph, that goes up like this and gets steeper and steeper, in particular graphs where p is bigger than 1. When we take a reciprocal, then that's going to go down to the axis really, really fast. Okay, but for the y equals x to the 1/2 or x to the 1/3 or anything like that,
anything that's less than 1. Notice as we go this way, or x to the 2/3 or anything like that, as we go this way, it'll the slope actually decreases over is decreasing, even though it's going. Like you can take a derivative. When you take a derivative of the power rule, when you subtract 1, you get a negative exponent, which means it's going to be like one of these graphs anyway, going down, and so the slope is going down. Okay, even just in fact, yeah, and so we can actually see that even in a derivative calculation, the slope is going down on these. Now, as the slope's going down, we're heading toward infinity, but we're not going to infinity very fast. So when you take a reciprocal, it's almost as if we're not going to 0 very fast. So you can expect divergence over here when we take a reciprocal that way. Now, however, over here, notice how this is very steeply and quickly goes to 0. So when we take a reciprocal, it's as if we're heading toward this axis very fast, very extremely fast. So we do get convergence. Now, on the other hand, for y equals x squared, we're kind of going a slow rate to 0, kind of, see how the slope kind of goes like this. So when we take a reciprocal, it's almost as if we're not going to this axis fast enough, so we'll have divergence. So this might give you an intuitive sense for when you know that an integral will converge or diverge when it's x to negative p. In fact, let's just kind of look at that. So some examples. So if we have the integral from maybe 0 to 4 of x cubed, well, it's actually next to the negative 3 because we're dealing with negatives. Okay, x to the negative 3 dx. Does this converge or diverge? Now, there's a problem because we can't put a 0 in with a negative exponent. That'd be like 1 over, and it wouldn't work. So there's a problem. But realize that this 3, right, this is like one of those things that go up like this. And so when we take a reciprocal, it's not going to be going that way fast enough. And so it'll diverge. And also kind of, we have these two schematics to work with. We have, we have the diverge, converge if p is bigger than 1. And then we also have the converge, diverge if p is less than 1, like that. Okay, as we go along. So this one diverges. If we have x to the negative 2/3 and we're going from 0 to 4, this one right here will converge because it's right, it matches this one right here. Now, if we did 7 to infinity of x to the negative 4/5, now we're in this range here, so it'll actually dx, this will actually diverge. Okay, because we're going off that way. And then one more, if we have an integral and maybe we have like x to the negative 5 and we're going from 11 off to infinity dx, this one will converge since we're in this place and we're going that way, so we'll have convergence. Thanks for watching.